Today we are solving LeetCode 209 minimum size subarray sum. This is a medium problem, but it teaches one of the most important techniques in arrays, the sliding window. In this problem, we will learn five important DSA concepts. First, what is a subarray? Second, how to find the sum of a continuous part of an array. Third, why brute force becomes too slow. Fourth, how sliding window works when all numbers are positive. And fifth, how to carefully move left and right pointers without making index mistakes. Let us understand the problem first. We are given an array of positive integers called nums. We are also given a positive integer target. We have to find the minimum length of a subarray whose sum is greater than or equal to target. If no such subarray exists, we return 0. Now remember, subarray means continuous part of the array. So this in this array, target equal to 7 and nums equal to 3, 1, 2, 4, 3. And the subarray 4, 3 has sum 7. Its length is 2. So the answer is 2. We are not asking for the subarray itself. We only need the minimum length. Now let us first think about the brute force solution. The simple idea is try every possible starting index. For each starting index, keep adding elements one by one. Whenever the sum becomes greater than or equal to target, we calculate the length. Then we update the minimum length. Now let's take the example of nums equals 2, 3, 1, 2, 4, 3. So we start with index 0. Then we observe 2 is less than 7. Target is our 7. Target equals. So 2 is less than 7. We add 3 to the list. And 2 plus 3 equals 5. Less than 7. We move next. 2 plus 3 plus 1 equals 6. Again less than 7. Then 2 plus 3 plus 1 plus 2 equals 8. That is greater than equal to 7. So length equals 4. Now we start with index 1. 3 is less than 7. So we add one more element. 3 plus 1 equals 4 less than 7. We add one more. 3 plus 1 plus 2 equals 6. That is again less than 7. So we add one more element. 3 plus 1 plus 2 plus 4 equals 10. That is greater than equal to 7. So length equals 4. And minimum length remains 4 only. Now start with index 2. So 1 is less than 7. We add one more element. 1 plus 2 equals 3 less than 7. We add one more index. 1 plus 2 plus 4 equals 7. That is greater than equal to 7. So we say length equals 3, and 3 is our minimum length now. Now start with index 3. So this is index 3. So 2 is less than 7. So we add one more element. 2 plus 4, that is equal to 6, less than 7. So we add one more. 2 plus 4 plus 3 equals 9, that is greater than equal to 7. So we stop and say length equals 3. Now we start with index 4. So 4 is less than 7. We add one more element, 4 plus 3 equals 7, that is greater than equal to 7. So we stop and say length equals 2. This is our minimum length now. Now we start with final index 5, and that is 3. 3 is less than 7. And now there is no other element. So no length value for this index. So our answer is the minimum one. Answer equals to 2. Now this works, but the problem is constraints. If you look at the constraint, so num dot length goes to 10 power 5. So it it gets the answer in order of n square. Num dot length can be up to power 10 power 5. If we try all the subarrays, the time complexity can become order of n square. That is too slow. So time is order of n square. That is very slow. So we need a better approach. The important observation is all numbers are positive. This is very important because all numbers are positive. When we move the right pointer forward, the sum can only increase. And when we move the left pointer forward, the sum can only decrease. So this is the important observation. All numbers are positive. When we move the right pointer forward, the sum can only increase. And when we move the left pointer forward, the sum can only decrease. This allows us to use the sliding window technique. We will maintain a window from left to right. This window represents a current subarray. So we will use sliding window technique. So whenever we see that when we move the right pointer forward and something happens, and when we move the left pointer forward, then something opposite to that happens. Then we can use the sliding window technique. So we will maintain a window from left to right. Let me write down what this technique is. So we will maintain a window from left to right. This window represents a current subarray. Now keep adding nums right into the sum. Whenever the sum becomes greater than or equal to target, we have found a valid window. But do not stop there. We try to shrink the window from the left side to make it smaller. Why? Because the question asks for minimum length. So the logic is expand from the right until the sum becomes valid, and then shrink from the left while the sum is still valid. So this is a very simple technique, although words can be confusing. So during shrinking, keep updating the minimum length. Now let us write the pseudocode. So we initialize left equal to 0 and initialize current sum equals 0. Initialize min length equals infinity, maximum possible number. Now loop from 0 to n minus 1. Add nums right to current sum. Now while current sum is equal to greater than or equal to target, Calculate current window length as right minus left plus 1. We keep increasing the left while current sum is greater than or equal to target. We keep increasing the left. And once the while loop ends, we calculate current window length as right minus left plus 1. This is one of our answer. This is a probable answer. So we update the min length. Then remove nums left from current sum and move left forward by 1. At the end, if min length is still infinity, return 0. Otherwise, we return min length. So that's it. So we can easily understand this when we will look at the dry run part. First of all, let us code this. So we initial left equal to 0, current sum equal to 0, and min length equals infinity. Then for right in range, len nums. We do current sum plus equals nums right. And if it happens sometime that our current sum is greater than target, then we do this. Current length, we get the current length, update the current length, and then update the min length. Current sum equals minus equals nums left, and left plus equals 1. If min length is, then we come back to the for loop. We go outside the for loop and check if min length is equal to infinity, we return 0. Otherwise, we return the min length. So let us dry run this. Let us dry run this code. So let me switch to pen paper view. Let me increase its size. Now let's try to dry run this code. So target equals 7, and nums equals 2, 3, 1. comma 2, comma 4, comma 3. So initially, let's write the variables on one side. So left current sum, min length, and right. So initially our left equals 0, current sum equals 0, min length equals infinity, and right is in len nums. So len nums equals 1, 2, 3, 4, 5, 6. It is 6. So it is 0, 1, 2, 3, 4, 5, and pointer is on 0. So my current sum plus equals nums right. If I go to this line, current sum plus equals nums right. So I need to add nums right to the current sum. So what is my nums right? Nums right is my nums 0. Num 0 is 2. So my current sum will become 2. Now what I need to do, I need to check if current sum is greater than equal target or not. So current sum is not greater than equal target. So I will uh, go to the next pointer, that is next right value, that is 1. So I will check again. I will do again update the current sum again by nums right. So current sum plus equals nums right. So it will become nums 1 is 3. So 2 plus 3 is equal to 5. It will become 5. Now 5 is not greater than equal target. So I will again go to the next. Right will become 2. Now my nums 2 is 1. So I will add this. 5 plus 1 is 6. Again it is not greater than target. So it will again increase. And my nums 3 is 2. And current sum will become 8. So it is greater than equal target. So this is true this time. Now current length will become right minus left plus 1. So current length, that will become right minus left. Right value is 3, left value is 0. So 3 minus 0 plus 1 equals 4. And min length will become min of min length and current length. So it will become 4. And then I do current sum minus equals nums left. So current sum will become nums left is 0. So minus 2. So it will become 6. And then left will increase by 1. Now I will again go back and my right will increase. Sorry, the while loop will continue. So is my current sum is greater than equal target? So this condition is false now. So I will go to the next right value. My next right value is 4. So what is that is 4. Now 4 is 4. My current sum will become 10. Now 10 is greater than target. 10 is greater than target. So current length will become right minus left plus 1. So this will be updated. It will become right 4 minus 1 plus 1 equals 4 again. Now my min length will be remain the same. Min length will remain the same, and current sum minus equals nums left. Now my current sum equals nums left, that is 3. So 10 minus 3 is 7, and left will become plus 1, that is 2. Now my right will increase, go to 5, and nums 5 is 3, and 7 plus 3 is 10. So my current sum will become 10. Now current sum is greater than equal to target. This condition is true. So my current length will become right minus left plus 1. It will become right 5 minus 2 plus 1. That is again 4. Min length will remain the same. Now current sum minus equals nums left. So it will become nums 2 is 1. So it will become 9. And left plus equals 1. So it becomes 3. Now we increase the value of the loop is still true. The while loop is still true because my current sum is greater than the target. My while loop is still true. Current sum is greater than equal to target. So what I will do, I will do current length, update the current length. That will become right minus left plus 1 equals 2 plus 1 equals 3. Now I will update the min length to be 3. Then current sum will be minus nums left. Nums left is nums 3. That is 2. So it becomes 7. So still the condition is true. Current sum is greater than equal to target. So I will update the current length. Current length will become also I will update the left value 4. So my current length will become right minus left plus 1. Right is 5 minus 4 plus 1 equals 2. And I will update the min length equals 2. Now I do current sum minus equals nums left. Nums left is nums 4. So it is 4. 7 minus 4 is 3. Now this condition is not true. This condition is false now. So while loop will end, and now there is no other pointer. So for loop also ends. So our answer becomes this min length. We return the min length. So this is the complete dry run. Now let us analyze the time complexity. So the right pointer moves from left to right once. Let me show a visualization. What we are doing is, this is an array. So there are multiple elements, and we are keeping, here is our left and here is our right. So when this is a sliding window, so first we increase the right in this direction, and once some condition is satisfied, then we start increasing left in this direction. And if the condition is unsatisfied, then we again move the right. So in this way, our windows keeps on shifting from starting of the array to the end, and whenever and we keep on storing the minimum length. So once we've gone through all the sliding windows, valid sliding windows, then we return the minimum length. a very simple question. And the total time complexity is order n. Time equals order n because we are looking at a single number at most twice. Uh, Either the right pointer may point that number or left or both may point the same number. So at most we are looking at two times a same number. So it is of order n because it increases linearly with the length of the array. And the space complexity is order 1. Space equals order 1 because we only use a few variables. Okay. So now let us understand the follow-up. The follow-up asks for an order n log n solution that can be done using prefix sum and binary search. Since all the numbers are positive, the prefix sum array will be strictly increasing. For every starting index, we can binary search on the smallest ending index where the subarray sum becomes at least target. But the sliding window solution is better because it solves the problem in order n. So this is a better solution. Let us run this solution first before we discuss critical mistakes. Just a minute, let me log in. Let us try to run this. Okay, it is passes. Let us submit this. Let's see all the test cases passes or not. So yes, all the test cases have passed. Now finally let us discuss the critical mistakes. So first one is confusing subarray with subsequence. Subarray must be continuous. Then second mistake is using if instead of while. When current sum becomes greater than or equal to target, we may need to shrink multiple times. That is why we use while current sum greater than equal to target. Third mistake is calculating length incorrectly. The correct length is right minus left plus 1. The plus 1 is important because both left and right are included. And fourth mistake is moving left before removing nums left. So we need to remove nums left also. We should first subtract nums left, then increase left. And fifth mistake is forgetting the case when no valid subarray exists. If min length remains infinity, return 0. So the main idea is simple. Keep expanding the window from the right. Whenever the sum becomes valid, shrink from the left. Keep recording the smallest valid window. This is a sliding window pattern, and it is very useful whenever we are working with continuous subarrays and positive numbers. That is it for LeetCode 209 minimum size subarray sum.